V3 will also be equal. So we're going to be looking at some calculations that will help us understand how to apply these rules. We're going to what we're going to do here, what we're going to be doing is to subtract these two. Hello everyone, welcome to Study Guide Forum. Today we are going to be looking at gas law. This is one of the important law, gas law, that help us understand the behavior of gases at constant pressure. That is, it helps us understand the behavior of gases, volume of gas with temperature. And then this law says that for a given mass of a gas at constant pressure, that the volume, each volume is what? Directly proportional to its absolute temperature. This absolute temperature has to do with the temperature at what? Kelvin scale. That means absolute temperature, when the temperature, in fact, it is believed that the absolute temperature, zero temperature, 0 Kelvin, at 0 Kelvin, that everything ceases to move. So that is to say, if we are looking at this Charles law and we want to apply it, deal with it mathematically, what it simply means is that the volume is directly proportional to temperature. Now, if we are to apply constants, that means volume is equal to temperature. Volume is equal to constant times what? Temperature. So to get the value of this constant would then mean volume over T. So having this at the back of our mind, what we have here now is that if we are comparing two gases, it means that V1, T1 is equal to V2 over what? T2. Since the constant is constant no matter the level or the volume or the temperature. As the temperature changes, the constant remains the same for each of its values. The constant remains the same. So if we have to do this now, it simply means if there's another gas we are looking at, that means V3 will also be equal. So we're going to be looking at some calculations that will help us understand how to apply these rules. We're going to questions that will help us understand this chart or how to apply it. The first question we have here is say that a fixed mass of gas of volume 500 cm³ at 0 degrees Celsius is heated at a constant pressure. What is the volume? What is the volume of the gas at 3 degrees Celsius? Now the first thing we do here, because we know that Charles law is valid at what? Absolute temperature, that is Kelvin temperature. Now before you apply this our formula we have already stated earlier on. So before you can do this, the temperature must be what? At Kelvin. That's why you must also you need to convert all the temperatures, because we have the temperatures here. Temperatures here are what? In Celsius scale. So our volume here, V1, our V1 is what? 500 cm³. Our T1 will then be, since it's 0, converting to Kelvin. 273 plus 0 will give us 273 Kelvin. So our V2, the volume we are looking for, this is unknown, the unknown volume, and then the temperature again, the T2, the second temperature, that will be 273 plus 3, that will give us 276 Kelvin. Now we can then easily apply our formula that we have there. The V1 is 500, while the T1 is equal to volume, the new volume we are looking for over the new temperature, which is 276. So if we cross multiply this, if we cross multiply, we will have 273 V2 equal to 500 times 276. So V2 will then be 500 times 276 all over 273. So by dividing what we have here, divide by 273, it means that our volume will be 500 multiplied by 276 divided by 273. So what we have will be approximately 505.5 cm cube, or we can say 506 cm cube. That's our final answer. If you are joining us for the first time, we encourage you to subscribe and share. Also like. If you have any question, you can leave it in the comment section. We will always attend to you, and we want to hear from you from the comment. Tell us what you feel. Feel free to say whatever you think and you feel about our class today. So let's go back to what we have. What we have at this moment again is the second question. We'll be able to solve this. So let's look at the second question. Say that the fixed mass of gas of volume 60 cm cube at 0 degrees Celsius. Now the question said find the temperature at which its volume will become 70 cm cube, assuming that the pressure remains constant. Since the pressure remains constant, it means that we are applying the same formula that we have already. So what does it mean? We are going to substitute everything that we have there. So here we have V1 is 60 cm cube, and our first temperature is then 2 plus 0, 273 plus 0, that will give us 273 Kelvin. Now the second one, the next volume V2, which is 70 cm cube, and the temperature is what we don't know. The T2 is unknown. We call it unknown. So we have it as unknown. So now we substitute. If we are substituting, we have the 60 over what? 273 equal to 70 over what? T2, the one we don't know. If we cross multiply, what we're going to be, T2 will then be 273 times 70 all over 60. So let's see what we will get here. 273 multiplied 70 divided by 60. What we have will be 318.5. That is Kelvin. This is in Kelvin, remember. So now if we are to get it in if we want to return it back to Celsius temperature, what we are going to do here, what we're going to be doing is to subtract these 318.5 minus 273 3. That will give us what? To give us 5.5 degree Celsius. That is what we have. All right. Thank you so much for being part of the class. We're happy that you get to this point, and we want to hear from you. Meanwhile, the question you have here will be in the description of this video, and then we want to hear from you. Make sure you like, share. Bye.